Let's look at 2.3 part 2. All right, we're going to look at what's called a weighted mean. I'll show you what that means in a few minutes, but it is like GPA. So we'll do a little practicing of figuring out your GPA. So on the top, you're going to multiply the entries times their weights and add those up. And then on the bottom, you're going to add up the weights. So let's look at an example. Right, let's take a look at GPA. So with GPA, we have set weights, right? A is worth 4 points, B is worth 3 points, C is 2 points, D is 1 point, and F is 0 points. Okay, so we are going to look at someone's grades here. So their final grades are right here. They have a C, a D, an A, a C, and a B. Okay, and let's put the points next to them. So these are the points. Right, so a C gets 2 points, so I put 2 next to the C's. A D gets 1 point, an A gets 4 points, C gets 2 points, and a B gets 3 points. So all I'm doing is changing the letters into points. Now, these classes had different credit hours. So one of the C's had 3 credit hours, but the other one had 4 credit hours. So this is where it becomes weighted. So the 4 credit hour class counts more than the 3 credit, and that counts more than the 1 credit down here. So we do have to add up all our credit hours. This person took 16 credit hours if you add all those up, and so that goes on the bottom in the denominator. But the weighted part is that we have to take the points times the credit hours. So that first class, we got 2 points for the C times 3 credit hours. So you get 6 points total. The next one, you get 2 points for the C times 4, so that would be 8. The next one, you get 1 point for the D times 1 credit hour. The A is awesome. You get 4 points for the 3 credit hours, so that gives you 12, and so on. We get 4, and we get 9. So we need to add all of those up. That's what's going on up here in the numerator. We just went ahead and multiplied them together. So if you add all these up, you would get 40. So now to get the average or the weighted mean, we're going to take 40 divided by 16, and that means that this person has a GPA of 2.50. We usually use 2 decimal places for GPA. All right, so this lays it out without any of my writing. You have the points in the first column. You have the credit hours in the second column, which we added up because that's our denominator. And then we multiplied those together. So you multiplied the points times the credit hours. That is this last column. And if you add up all the points that you got, even weighted by the credit hours, that gave us 40. So 40 over 16 gave us a GPA of 2.5. All right, so this just shows you if you have a frequency distribution, but we're actually going to let StackCrunch do this work. What you would have to do if you were doing it by hand is you would have to find the midpoint. We know how to do that. You have to find the midpoint of each class where you add the lower limit to the upper limit and divide by 2. Then you would have to multiply the midpoint times the frequency, and then finally divide by the sum of the frequencies. So it's actually quite a bit of work. We'll let StackCrunch do it. Okay, so this is a problem kind of like the homework problems. It says approximate the mean of the frequency distribution. So when you see that, that's different. You're not going to use summary stats column. When you have frequency distribution, we are actually going to use stat, summary stat, and then this grouped and binned. So what we're going to do is we're going to hit the box right next to the data. By hitting that box, all of the data comes into StackCrunch, which is awesome. Right, so the ages are in the first column, frequencies in the second column. At that point, we can go up and we can hit stat, summary stats, grouped and binned. We're going to put the age in the first column. Those are our bins, those are our classes. The counts are the frequencies, so we're going to put, and this is a drop-down window to just grab your data. Then we'll come down here and click mean. If they wanted something else, we would click that also. But for this problem, they only want mean. So we'll click mean, we'll hit compute, and look at that. It did all that work for us. Otherwise, we would have had to go all the way down. We would have to find midpoint for every single one, multiply the midpoint times the frequency, add those all up. It would be craziness. So we are very happy we have StatCrunch. Let's see, we want one decimal place. And so the mean is 42.3. It doesn't really look like a 4. Okay, so when we look at frequency distributions, we usually look at a bar graph to see what's going on. And we have a couple things going on, and I'm going to show you the visuals in just a minute. But we have a symmetric. So a symmetric is when the left-hand side looks just like the right-hand side. They're mirror images. We have a uniform. That's rectangular. That's when everything has equal frequencies. I'll show you that in just a minute. And then we have a skewed left, and we have a skewed right. So let's take a look at it. It's much easier to look at these with the graph. Okay, so this first graph in the upper right or left-hand corner, excuse me, this is symmetric. And it's kind of a bell-shaped curve. We're going to be looking at a lot of these curves. What would happen is if I folded this bar chart in the middle, the left-hand side would lay right on top of the right-hand side, right? There's a mirror image. So we call that symmetric. And when it's symmetric, the mean, median, and mode are all the same, right smack dab in the middle. Now this next one on the top right is what we call a uniform distribution. It's really symmetric also because if we folded it in half, the left side would sit right on top of the right side. They would mirror each other. There's not going to be a mode because everybody has the same frequency, but there is a median and a mean that's going to be right in the middle. Okay, then we have this skewing. So what happens is we have to look at where the tail is. This one's not quite as obvious, but you can see that it's not symmetric like the one up here on the top. And so it actually has a tail on one side and then goes like this. And so the tail over here tells us the skew. If the tail is on the left-hand side, then it's skewed left. If like this one, the tail is on the right-hand side, and then it's going to be skewed right. So look at where the tail is to know the skewing. All right, so let's take a look here. So we have, we want to know if this is symmetric, skewed left, or skewed right. Well, we can see the tail is way over here on the left. If we added a curve to it, it would look like this. I'm not doing very well with my curves. And so it is skewed left. Now, what happens with skewing is that the mean is going to be where the tail is. Okay, so let's look at mode first. So mode is going to be the largest bar. Well, the largest bar is C, that's the tallest. And so the mode is the data entry that has the highest frequency. We know that. That's the data entry that shows up the most times. That has to be the tallest bar. In this case, that is C. Okay, the mean is going to be wherever the tail is. If it's symmetric, the mean's in the middle. But if it's skewed left or skewed right, then the mean is going to be where the tail is. So in this case, the mean is going to be to the left of the median and the mode. And so that's actually going to be A up here. Okay, and then the median is the only one left, is B. It's going to be in the middle. So the median is between the mean and the mode for this graph. And so the median is to the right of the mean and to the left of the mode. Okay, so what's important is the mode is the tallest. The mean is going to always be on the side where the tail is. And then the median is the other one that's left.